All right, so what I want to do today is I want to start by talking about static methods. Now, to do that, I want to start with just a a program that we wrote last class, and that was like this math class. And you might recall that in this math class, we could do two things, two simple things. We could add two numbers together using the method addition, or we could get the remainder by using the percent sign, which is the mod. So these two methods, they're not void methods. They return a value, and specifically it's returning an integer. In order to use them, I have to do a couple of things here. I have to first create an object, and then, why is it giving me a bunch of errors here? Yeah, that'll do it. I have to first create an object, which we named Marvin because we're funny. And then once I've created that object, I can do marvin.addition. It's going to add those two numbers together. And then I'm going to do marvin.remainder to get the remainder there. So we print out, what would that be? 95 and then 35 after I compile and run this thing. Let's just do that real quick here, just so I can prove it to you. 95 and 5 because I don't know how to do a remainder, it turns out. What did I put in there? Oh, yes, 65. So 30 times 2 is 60, so that'd be a remainder of 5. Good for me. Figured that one out. Glad that's on the recording. Now, you don't necessarily have to create an object in order to be able to use a method. You can use something called a static method that will allow you to use the method without actually creating an object. Here's what I'm talking about. If you go to the method here, over here in the class, if you just add the word static in front of the int, what you're saying is, I want to allow this method to be used without creating an object. Now, where have you seen that word static before?
In all the programs.
It's in the main method, right? Public, static, void, main. Static just means you can use this method without creating an object. You can call it directly in a static way without an object. So let me show you what that means. So I'm just going to comment out this object here. And instead of doing marvin.addition, I'm going to call the class itself. And I called the class math. So I'm going to change it. So I no longer have a object. The object's gone. It's commented out. So I never created the object. Instead, I'm just calling that function, that method directly. I'm saying, hey, I want to use this addition method. And when you do that, when you add that one little word, it allows you to call that method in a static way, and you get the exact same answer. Now, you can still, even if it's a static method, you can still call the object, create the object, instantiate the object, and use it, even if it's a static method. So this just gives you a little bit more flexibility to either call the methods in a static way or to create an object first. So something I'd recommend you do for most of your methods, just go ahead and add the word static in there if it makes sense. Anytime you're returning a value, add the word static, and then you can still create an object to use it, or you can call it without creating an object. It gives your program a little bit more flexibility, and that's what that word static is going to do. Okay, so we did some math here, but Java comes with a whole bunch of other math built in. And every math method is a static method. So you can create an object and use the math class, but you don't have to. In fact, I think we were doing this a couple classes ago when we were doing the Java Math Lab. We're using like math.pow or maybe math.py. These are static methods that you can use without having to create an object first. And so I just want to show you some of those. And when I like to do that, I like to just use JDoodle. So I'm going to close out BlueJ here, and we're going to run some code. But before I do, I just want to show you some of the methods that we're going to be talking about here. All right, so the first one is math.floor. And the floor is it takes the number and it just rounds it down. So if you have 10.2 and you use the floor method, it's going to change it to 10. If you have 10.4, it's going to change it to 10. If you had 10.9, it's still going to round it down to 10 because floor always rounds it down. 10.999999999 still gets changed to 10. Ceiling does the exact opposite. It's just ceil, short for ceiling. It's going to round it up. So if you type in 9.6, it's going to change it to a 10. If you type 9.4, still going to change it to a 10. Not 9.0000001, still going to change it to a 10. So floor and ceiling don't round the way that you expect them to. It's always going to push it up or down, depending on which one you pick. Now, one that I have shown you before is math.pow. That's how you use exponents in Java. So it's x to the power of y. So if I wanted to do 3 squared, I would do pow 3 comma 2, and it would spit out a 9, because that's 3 to the second power. Abs is the absolute value. What's the absolute value of negative 4?
4.
What's the absolute value of 4?
4.
So absolute value is like distance. It's always positive. No matter what number you put in there, it's going to change it to a positive number. And then the one that you're going to need for the lab today when we're doing the quadratic formula is square root, which literally just takes the square root of a number, and it's SQRT. A couple more I want to show you before we try them out. Round is going to be the one that's going to round it properly. So if you had 10.4, round would round it to 10. But if you had 10.6, it would round it up to 11. All right, so the rounds it to the nearest whole number. Min will give you the smallest number between 2. So min 3 comma 10 would give you a 3. Max works the opposite. Max 3 comma 10 would give you a 10. Because min takes the lower value, max takes the higher value. Now the most interesting one here, and the one we're going to spend a lot of time on in just a second here, it's the last thing we're going to talk about before we write our program, is the random function. And math.random just returns a value between 0 and 1. A random number. You have no control over it, it just gives you a random number between 0 and 10. So I just want to show you how to use all these real quick. Yes, Lucas.
You can change like the range of numbers in random.
So glad you asked that. Ask me again in like 10 minutes.
Cool.
That is the question that we need to get to. Not 10 minutes. Like ask me again in like 4 minutes. Not gonna, if it takes me 10 minutes, this is going to be the worst video of all time. 10 minutes to figure out how to use ceiling. All right, so I'm just going to type some stuff in here, and I want you to tell me what you think is going to spit out, okay? So this math class, I can call it in a static way, so I don't have to create an object to use any of these math methods. I'm going to say math dot whatever I want. So I've not created an object. I'm calling all these math methods in a static way. So math dot, let's try floor, of 3.254. What do you suppose that's going to spit out? All right, we'll check it in a second here. How about, and I should just copy this stuff, shouldn't I? How about the other one? Math.ceil. What's that going to be?
4.
It's going to push it up to 4, you think. Okay, cool. How about math.pow? And let's do 2 comma 4. Anyone can do that one? What's 2 to the 4th power? That's 2 times 2 times 2 times 2. 16? Okay. Let's keep going. Let's do math.abs. That's how you get a 6-pack. And we'll type in a -6 there. What's that one going to be?
6.
That's going to be a 6. Okay, what if I just change that slightly and did +6? What would it be then?
6.
I think it's going to be 6. Okay, one more. Let's do math dot square root of, and let's just put a 9 in there. Wait. All right, last question, and then I'm going to run this thing. Would you expect these commands to output an integer or a double? And if you think it's one or the other, which ones should be doubles, which ones should be integers? Well, these two probably are not, the first two are probably not integers, right? Because they're already doubles. So that output should Well, maybe. I don't know. Maybe. I guess it's going to round to 3 or 4, right? So maybe they are integers. We'll check that.
3.0 over 4.0.
Say it again?
I might say like 3.0 or 4.0.
It could be a double, yeah. But I'm putting a double in, so maybe it changes it to an integer. I'm not sure.
Or maybe math is like a kind of cast. I don't know. Like it also casts. I don't know.
Okay, well, let me ask the question a different way. Do you expect any of them to be integer value?
Yeah.
Which one do you think would make sense for it to be an integer value?
Absolute value.
Abs, okay, could be an integer. Any of the other ones?
Square root of power.
Square root of 9 is 3. It could be an integer. Well, let's test it. Let's see. It turns out that almost all of these are doubles. And these are the values you were expecting. The floor of 3.254 was 3.0, so it changed it to it is a double. It didn't change it, it stayed a double. And the second one, ceiling, was a double as well. 2 to the 4th power, those are 2 integer values, but it changed it to a double, made it 16.0. The only ones that were integers were the absolute values. And then the last one was a double as well. That's the square root of 9. That changed it to a double. So something to be aware of. They're not always going to stay the same type. All right, I want to show you a couple more here, and then we're gonna write a program here. Let's do some rounding. Let's do math dot round, and let's just round 10.499. What's that going to be?
10.0.
Is that going to round up or round down?
No.
It's less than 0.5. It's going to round down, so it should be 10 or 10.0. All right, we'll check that in a second here. Let's try math.min, and let's do 10 and -7. What's that one going to spit out? Smaller numbers, -7. Okay, how about the other way? Math.max of 10 and 1,000. What is it going to spit out there? Okay, and the last one I want to do is, let's just show you how round works. Random. Math.random. And that one, I'm not going to put any values in there. Math.random, just a set of parentheses. So let's check these real quick here. So that one did round to 10, and that one round did change it into an integer. It's not a double, it's just 10. And also, we had an integer value for the minimum value of -7 and the maximum value of 1,000. So all 3 of those are integer values. That's kind of interesting. Just be aware as you're using these, the types might change and they might not. Now here, that sure looks like a random number between 0 and 1. Let's talk about that a little bit more. So Lucas, I want you to ask me that question again that I told you had to wait 4 minutes to ask me.
So can you make it so that it chooses a different array of numbers, like a one?
Yeah. So right now, the answer is yes. And this is a question that's going to be on the quiz next time, so I'm glad you asked me. Right now, this gives me a random number between 0 and 1. Can you conceive of an operation I could do to make this print out a random number between 0 and 10? What could I do to make it 0 to 10? Add, subtract, multiply, or divide. Because right now it's 0 to 1, but I want it to go 0 to 10. Is it add? What would you add?
9.
So if I did +9, that's going to give me a random number between 0 and 1, plus 9. So that'd give me a random number between 9 and 10. But I want a number between 0 and 10. Multiply by 10. And let's just repeat this a few times so that we can convince ourselves this is going to give me a random number between 0 and 10. There we go. I got 5 random numbers, and they're all between 0 and 10. Lucas, in the back.
Like a negative number, like specific.
So like I could do multiply by -10. Is that what you're asking me? So let's do that one last. Let's do something simpler first. But yeah, so hold on to that thought just a second. Leo?
Could you make it random to infinity?
So the computer doesn't understand infinity, but you could like type in the biggest integer that it will allow, which I think is like 32 zeros or something. Let's see if that errors it out. Yeah, that's too big, too large. Yeah, so I think I got to get rid of a couple zeros there. Sorry, I can't count. That might be billions there. It's really good. This is somebody's watching this video right now and being like, "What the hell is going on? What is this?" There it goes. But yeah. But look, the number's so large that I put it in scientific notation, so you still have to be able to convert that from scientific notation to. Yeah, Lucas.
Can you cast the numbers so it's only integers?
I don't know.
So like if you're to like make it like a D&D game or something. That's the
Let's check.
Yes, maybe. I don't know.
The answer is yes, you can. You can cast it as an integer.
Wait, was it just an error? Can you run it one more time to make sure it wasn't just like it's always going to be equal to 0?
Sure. I like where your head's at.
Well, it's always 0.
So I need to put an extra set of parentheses here because it's casting the random number as an integer, so it's always going to be 0. And so I need
because it's casting 0 to 1.
Right. So I need to multiply it by 10 first, and that'll do it.
3, 8, 2.
All right, nerds. There you go. Now you can play D&D.
That'll be my final project.
Good. That'll be fun. All right. So we need to work our way up to Lucas's question. Before we can do that, this gives me a random number between 0 and 10. What if I want to do a random number between 1 and 10?
U plus 1.
All right. So add 1. Is this going to give me a random number between 1 and 10?
I'll give you a random number.
You add
11, right? Shouldn't
1
be
and
times 9
11.
plus
You
1.
multiply by 2, and then you add 1, then multiply by 2.
4 times 9, then add 1.
Multiply by 2, then divide by 2.
Yes.
Can you put arguments inside the parentheses?
I don't think the random takes any arguments. So we got to do it this way. So this would give us 1 to 11. To make it 1 to 10, just change that 10 to a 9. So here's how I usually think about it. What's 10? So I want to go 1 to 10. What's 10 minus 1?
9.
That's the number that goes right here. And then what's the first number?
1.
1 is what goes right there. So how could I get a random number between 12 and 16?
You multiply by 16.
What's 16 minus 12?
12. You multiply by 4.
Multiply by 4, because 16 minus 12 is 4, and then add the first number, 12. This should give me a random number between 12 and 16. Let's just test it, make sure it's working. Are all of these random numbers between 12 and 16?
Yeah.
Okay, so now let's do the hard one. Lucas, I want you to ask me that question again. Same exact question you asked me a couple minutes ago. Okay, so what's 12 minus negative 5?
17.
So I'm going to multiply by 17.
That doesn't look good.
And what's the first number? So instead of adding 12, I'm going to subtract 5. Or think about it as plus negative 5. Exactly. All right, so let's just make sure this is giving me random numbers between negative 5 and positive 12. I want to see if I can get a negative number here. There's one. Okay. All right. So that's going to be a question on the quiz. All right, so it's something you should probably mess around with, and I'll show you a place where you can practice that by the end of class. But just think about it this way. Multiplying by the difference between the two numbers, and then adding the first number. In this case, I was adding a negative 5. All right, that was a good question. All right, that's all I wanted to teach you today. Now I want to write a program. All right. In a moment here, you're going to do a lab. And on this lab, you are going to ask a user, what is a quadratic equation? And they can type in any quadratic equation they want. And then you're going to find the roots. So you're going to have to use the quadratic formula to find those roots. We'll talk about that in a second here. Before we get there, though, I want to write a very similar program. But I'm going to ask the user, hey, what is your first point? What's your second point? And then I want to calculate the slope between those 2 points. Anybody remember the slope formula from Algebra 1?
y2 minus y1 over x2 minus x1.
Rise over 1, which is y2 minus y1 over x2.
Or delta y over delta x, I think.
Yeah, same thing. Yes. Excellent. So let's do it. First thing I need to do is I need to make a new project. And I'm going to call this thing slope. Close enough. I'm going to make a new folder for this. I'm going to call it slope. Let's hear it.
Make a project, right? It makes it in a folder already. So why don't you just put it inside that folder?
Because that one was in a full. That was the last project I did, and I'm trying to. So here, let me.
Yeah, but like whenever you like open a project, right, and you try and find them, you click on like math, and then it opens another math folder. They click on again.
Are you trying to tell me how to? I need to organize better. Is that what you're trying to
I'm
tell
just
me?
curious.
Do you want to teach classics?
Maybe.
It'd be more
Yeah.
efficient.
So
Like if you click on period 3, right, you open like math.
But that was the. Oh yeah, there's another one. Oh, so you're saying just put it here
Yeah.
and then create it, and then just select this one and call it slope.
Yeah.
Oh yeah, that's a lot smarter, isn't it? Oh, path already exists because I've already created it. Yeah, that would work.
Okay.
Thanks for making me look like an idiot on my own video. Like and subscribe. Like and subscribe. Okay, I want to make a new class here. Remember, whenever you name a class, the first letter is always capitalized. So I'm going to call this thing slope. All right. And in slope, this particular class is only going to have one method. It's only going to be able to do one thing. And that method is going to be get slope. All right. Now, before I think about how to calculate slope, let's think about what needs to go here first. So we want other things to be able to access this particular method. We want to be able to call it. So we want to make this a public method. So I'm going to put public right there. And then we need to think about what this class is going to return. What kind of value? Is it going to return an integer value? Is it going to return a double? Is it going to return a string?
Double.
What would make sense in this case?
Double.
Yeah, because the slope can be like 3.5, right? It could be 2.75. So it should be a double. Now, this would be good enough. This would get it done. But at the beginning of class here, like 20 minutes ago, I said, it makes your program a little bit more flexible is you put the word static here as well. And this will allow you to use this method without creating an object. I'm going to create the object in a second here anyway, or maybe I won't. Maybe I won't. This allows you to use this method without creating an object. All right, just kind of saves you a step in your code. Sometimes that makes sense. Now, I need to know some things to calculate slope. What do I need to know?
The y2, y1.
All right, so I need to know an integer value. Let's say it's going to be an integer value. It could be a double. Let's assume that it's going to be an integer value, x1. How about an integer value, y1, integer value, x2, and an integer value, y2. So it's going to take in 4 parameters. And those parameters are just the coordinates, the x, y coordinates. Now, how do you calculate slope? y2 minus y1 divided by x2 minus x1. That's what I want to return. I want to take in those 4 values. I just want to return that equation. Now, I want to be real careful when I'm calculating this. I want to say, okay, y2 minus y1 in parentheses divided by x2 minus x1. That's really all the code this method needs. That's all it's going to do. It's just going to calculate slope. And it's going to calculate slope every time I call it. Wouldn't this have been helpful in Algebra 1? What's the slope between these 2 points? You could just type in instead of having to calculate it. Now, it's possible that when I type in these integer values, that this is going to end up being integer division, which means it could push out 0 instead of what I want it to push out, like maybe it's 0.5. What can I do to make sure that this isn't integer division, to ensure that it returns a double like it's supposed to?
Make everything that says int double.
That's one solution. Yes? What's another solution? Cast it. All right, so I could also cast this thing as a double, which would just be like this. And either one of those, you could change all these ints to doubles, and that would be fine. Or you can just cast it as a double to make sure that whatever the value returns is a double like it's supposed to be. So I've got this method, but it only exists in theory. Now I want to actually use it. So here's what I'm thinking. We say, hey, person sitting at the keyboard, give me 2 coordinates, x1, y1. Give me an x2 and a y2. I'm going to calculate the slope for you. I'm going to spit it out. So how do we do that? Well, we need a new class, and we're going to make the runner class. We're going to call it slope runner, which sounds a lot cooler than it is. Slope runner would be a fun game. Slope runner. And this is, we're going to put the runner inside the, we're going to put the main method inside the runner. So help me think about the main method. How do I do that? Public, static, void, main, string, brackets, args, parentheses. Okay, great. Now what I'm thinking is we need to ask the user something. In order to do that, we need the scanner class. So the first thing we need to do is import that scanner class. We need to say import java.util.scanner. All right. And then I need to create a scanner object. We know how to make objects now, right? We say, what do we want to name our scanner object?
Marty.
All right, Marty, you're a new scanner now. And whenever you declare a scanner, just make sure you say system.in inside the parentheses there. Now I've got this scanner, which is going to take some inputs here. All right, so now I can start asking some questions. But before I do, I kind of just want to tell the user what's going on. Like, what's this program? What am I doing? So I'm going to print out this program will calculate slope between 2 points. All right. Exclamation. I'm very excited about it. All right, so now we told them what it's going to do. Let's do it. Ask them a question. Whoops, I copied the wrong thing. Need that. Say enter x1. And I want to just declare a bunch of variables here. x1, y1, x2, y2. This isn't something I've directly shown you. When you're instantiating, when you're making new variables, you can make several at the same time, separated by a comma. That's okay. I think you saw that on the test, and some of you are like, whoa, can you do that? Yeah, you can do it. As long as you put some commas there, that's fine. You can declare multiple variables at the same time. So now I know what x1 is. x1 is Marty dot next int. Whatever they type in. Let's assume they're going to type in an integer value for now. They don't necessarily have to, but just for simplicity, let's assume that they're going to type in an integer. And now I just need to ask for the other ones, right? After x1, what do I need to know? I probably want to know what y1, that first y variable. And then I need to know x2 and y2. That didn't work. x2, thanks Marty, for champ. All right, so now I've got this x1, y1, x2, y2. I got two choices. I can either create a slope object and then call the method, or since I typed in the word static, I could just call the method directly from the slope class. Since we created some objects, I already created an object here. I don't really feel like making another one. I'm just going to call this thing statically, in a static way. I'm going to have one last system.out thing here. And this time I'm going to say the slope is, so I want to put that right there. And then in another system, and I'm not going to put print line because I just want to print on the same place, system.out.println. I'm just going to call the method. I'm going to say slope dot get slope. So I'm calling it statically. I'm calling this method without creating an object. I need to tell it the parameters though. X1, Y1, X2, and Y2. And I have no idea if this is going to work. Normally, as we go through, we want to test the program and make sure it works. So this is being recorded. I hope it works. Let's find out. I'm so nervous. I'm going to compile it. Oh, I screwed it up. I'm going to compile it. I'm going to run it. Okay, so it looks like it's running. Give me an XY coordinate. 2, 10. 2, 10. All right, give me another one. 7, negative what? Negative 5. So the slope is negative 3. How do I know if it's right?
Do the math.
Okay, let's do some math. So
It's not. Wait.
the math is, and sorry people in the video, you're not going to be able to see this, but I'm going to do 7 minus 2 divided by negative 5 minus 10. 7 minus 2 is 5. Negative 5 minus 10 is negative 15, which indeed is negative 3. Boom! It works. All right, but what if we put in some weirder numbers here? I want to show you one last thing, because we can make our program better. You should always ask yourself, how can I make this program better? So I'm going to put in some ugly numbers now. I'm going to put in 7, 13, and 12, 18. Nope, that wasn't ugly.
Wow.
Dang it. Dang it. 7, 20, and 4, 6. There it is. So see that repeating decimal? 4.66666666666. What if you didn't want that? What if instead you wanted to round it to 2 decimal places or 3? There's a way to format it to make it look nicer. And that's the last thing I'm going to add to this program. Instead of using print line, you can use print F. And F stands for format. It'll allow us to format it. And all we need to do in front of this method call is put in parentheses, in quotes, percent, dot, and how many decimal places do you want? Do you want 2? Do you want 3? Do you want 4? Let's say 3. At percent dot 3, we'll round this thing to 3 decimal places. Percent dot 2, we round it to 2 decimal places. Guess what percent dot 1 is going to do? 1 decimal place. So that's the last thing I wanted to add here. So let me type in some ugly numbers here. 7, 14, 4, and 6. Didn't work. Glad I got it on video. Oh, I forgot one piece. In the format here, you need to put /n. Now it'll work. 7, 20, 4, 6. Still not working. It's still broken. Oh, God.
It looks like you're missing a util for it. Does it need a hardware utility?
I might have to put the star right here. Yeah, that's probably going to do it. You have to import it. 7/24/6. Nope, I didn't solve
Jace
it.
has an idea.
It's gonna be the worst. Tell me the idea.
You said we put this back after the 3.
0.3, I think so.
No, it's definitely percent dot to. Oh, it is. It is an F. You're right. Jace was right. He gets credit. Jace gets credit on the video. Thank you, Jace, for saving my video. All right, one more try. 7. I'm gonna have to edit this thing so much. 4,6. There it is. 3 decimal places. I will post this code up on Schoology. So yeah, that is a little complicated, but you'll find that on Schoology. All right, that little piece right there. That's one of the things I'm going to ask you to do in your code for the lab today. Is I'm going to ask you to format it to like 2 decimal places. All right, so that's it. Say bye to everybody in the video.
Bye.
Thanks for watching.